Good afternoon. I don't think we got good morning today, but starting on the top of the hour, unless we got some people joining later from the Pacific time. But good afternoon, Gabe. Good evening, wherever you're joining from. Thank you for joining us today. We'll probably give a minute or two for anybody else to join. But thank you for joining. This is part of the Houston Fabric user group, and we are excited to have Thrushna as a guest today, who's going to be giving us an idea about real-time analytics. And there's a lot of buzz about it, but this is something I'm also curious to learn as much. So without further ado, Thrushna, why don't you maybe give us a little bit of introduction about yourself, and then we'll jump right into.
Yeah, sure. Thanks, Khalid. Thanks for the opportunity here. I'm going to speak today about real-time analytics in Microsoft Fabric. I have a quick introduction slide about myself. I've been in the industry for quite some time. I've been doing data. I've been in the data space for over 13 plus years. Worked on various data management projects and various technology stacks. My biggest asset, and I would say my skill set, would lie in eliminating the data silos and working through the consolidations and data integrations. In any industry that I've worked on, that was the biggest challenge that we've seen: data coming from multiple data systems, but not having a unified source of truth data. And using Fabric and Snowflake and other technologies in the past have implemented, a single unified data warehouse for the companies to, flourish there. One of the biggest things that I've always passionate about and working about is making sure we have more stabilized environments, and automation is always in place to make sure we're efficient there. I've also, been building innovative platforms for fleet, healthcare, and financial industries. So yeah, that's me in a nutshell.
I do have questions, obviously, and then I will try to keep an eye out for the chat as the question come on. I can give you a little bit heads up. I would put you on the spot, so I don't so essentially. Apart from RTI, towards the end of the thing, when we have a discussion, I have actually implemented Snowflake before myself. Specifically, this is pre-Fabric days, where I moved actually away from Synapse into Snowflake and whatnot. I want to kind of get your idea, not just to RTI, but your experience about where Snowflake shines, where Fabric shines, and how would you advise there. But other than that, let's jump straight into it.
Sure. If we have the audience, I'm ready here. So today's agenda is going to be exploring Microsoft Fabric, as Khalid had mentioned here. So I'm going to go deep dive into how we can build one unified data platform using Fabric, and what are the key capabilities of Fabric as well, and how we can do real-time analytics using Fabric. Fabric has multiple pieces and services. So we're just speaking on the event service here, event hub here, but this is just for the real-time flow. We could use Fabric for a number of things, but I'm just trying to be very, narrowed down to the real-time data streaming here, and how the architecture and data flows through, and what are the challenges that you would face while using, and what have we overcome to not using Fabric, and the final conclusions. So challenges before Fabric. So I would like to quickly go over why I think Khaled brought to the point where why have you gone to Fabric, right? So different tools. So if you see within AWS as well or other, I don't want to pick on any specific tech stack here, but to see if in the market you see that you have various tools available for data engineering, be it machine learning and business intelligence, or data pipelines. Everything is scattered in different areas, and you just have to have multiple clusters spun up, multiple instances spun up. You need, even though if it's cloud, you still need that setup to be done. But with Fabric, what happens is, again, I'm going ahead here, but just trying to give you a glimpse of what could Fabric bring in here, is where you would have one instance set up, and you could do anything, either it be engineering, machine learning, BI, everything is segmented into one area, and from there you could go flourish. That's where fragmented experience comes into picture with Fabric. Obviously, complex integrations of having in the prior to Fabric is having Power BI, Azure Databricks, and ML operations happening, and Azure Synapses. They were all different things that we had to explore. But now with Fabric, you could just spin up anything and do your POCs there. Siloed teams as well. Like I said, data engineering had their own wing, data science had their own area of going and doing their analytics. BI tools that we would explore is Power BI or Looker, be it Cognos and the Data Times, or Tableau, any kind of reporting, right? So they were all siloed into different teams. So those were the challenges that you would see without Fabric. But benefits of Fabric is everything is integrated. It's all in one place. You can just have one single unified experience with a single platform of having data in, be it in a data warehouse. A lake can be exposed to for data scientists to be able to do advanced analytics, simplified workflows through a data factory, and other features that we have within Microsoft Fabric. We can have collaborations. You just have to create one team and one project, and from there you could just have access given to multiple within your organization who could just come and look into the project right away. So the collaboration part has gone, and end-to-end management, right? You just don't have to be switching around different areas. You just have it's segregated. You can have ingestion pipelines going on in parallel to transformations pipelines, and then modeling, doing reporting and whatnot. Scalability, like Azure has a scalable infrastructure. You pick up whatever node you want or whatever cluster size you want, and you can go above and beyond that based on your needs. Why real-time analytics? Why should we do it, right? So basically, prior to I would not say prior to real-time analytics, we still do batch, but with batch data, we try to bring in data in a in less than a day. You always look at an hourly batch to be ingesting into the warehouse, right? But with real-time data, what we are trying to do is we are trying to connect to an event stream. From event, whenever IoT device has an event, it gets into the event pipeline immediately. It reads from that and pushes the data into event house. And real-time dashboarding can be done immediately through that. So you're trying to eliminate the silos of waiting on data, first of all, to be able to look at it and make insightful decisions out of it. That's where real-time analytics would come into play.
One question, Thrushna.
Go ahead.
So if I try to understand, like even from our perspective, if we're doing the like batch processing, right, we can essentially run the batches on like even at 5, 10, 15 minute or whichever case. However, the trigger happens from the engineering side versus the real time. The trigger actually happens from the data side. Whenever the event happens, that causes, I think, is that a right way to put how the real time differentiates from the regular engineering versus the real time?
Yes, correct. So you're always streaming in the real time. You're not waiting for something to be kicked off at an interval, because whenever there is an event, it triggers and you just get the event. Whereas in batch, it's just you're reading through the schedule or certain tasks to be kicked off. That's how we would differentiate it.
Even when we're doing like CDC change data capture and things like that, if it triggers when the record happens, it's more like real time versus if it's like you're running at 5 minute job to read logs, CDC might not be even real time because it waits for a certain schedule before it brings the data in, right?
Correct. So CDC essentially is near real time. I would not say real time because it has a lag of at least 5 minutes of reporting. But with real time, I think it is going to be under 30 seconds, or in some cases, based on how your requirements are, it could be under fractions of milliseconds as well, right? So it depends on the criteria on how you want to build. But yeah, the CDC aspect comes into picture for near real time. I would not call it real time, honestly.
Okay, no, that's really good. I think that's kind of like, for a lot of people that can be confusing, right? And I think that's kind of the demarcation that even CDC runs on a schedule versus a real time. It's essentially the data initiating, and then even in CDC, in best case scenario, we get about 5 minute latency versus near real time, as you mentioned.
Worked out for under certain minutes, but again, it might get expensive too. So it depends on the use case too, right?
Yeah, I think that's a very good point. I think this goes back to a discussion as I started my BI journey. This is like 2016. I was having a chat with Marco, and he goes like, if a project for like a batch, even if you try to get to like a couple of times a day and whatnot, it's about 100,000. The moment you try to get to real time, near real time, you just multiply that by 10, 15, whatever the scenario. But all right.
Correct. That's correct. So I think I really want to touch on the other points where we could have improved monitoring operational efficiencies. And why are we doing real time, right? To the point where we could detect anomalies and act proactively with real time data and enhance, obviously, customer experiences and be competitive. I think in many cases in today's world, nobody really wants to wait for us to run a report and see the output after an hour or so. They want it at the click of the button. So that's what real time comes into play. So competitive advantage is also a big thing that people have to look out for when you're trying to pitch between a batch or a near real time versus a real time analytics. So introduction to Microsoft Fabric here. So you see on the left, it's traditional databases, Azure SQL Server databases, where we're trying to. You could again, this is not something that I just took this up from the Fabric website, but this can be explored to any area, right? It can be any APIs, it can be any database, could be it Azure has connectors for almost every database that we could pull the data from. I didn't see any of those databases not being available, be it IBM DB2 or Oracle or Mongo, both structured, unstructured, semi-structured, anything. You have all the connectors that you could pull it from Fabric and use. You have multiple services here, but what I'm trying to say here is this is all catered into one layer. So you spin up one cluster, and on that cluster, anything can be built up. You just have all these for free, I should say, based on whatever you want to use. If your use case is data engineering, where you want to pull the data from source and dump it to a destination, be it S3, be it Snowflake, be it Azure data warehouse, anything, right? So it can be done with a data factory. You can pick real time. I'm trying to cater this only to real time today. We can expand more and have more sessions on the others, but for today's discussion, we're just trying to pull in the data from different streams here, just use different functionalities that can be done both for batch and real time, and push it to the one lake. And from one lake, it can be serviced for your reporting needs, or it can be for telemetry, it can be for the business KPIs. One lake serves as one interface there, and the reporting comes out through. For Power BI, it's usually standard analytics, but for real time data, we use real time intelligence. And for data warehousing, like Azure Fabric has its own data warehousing so that can sit, and we can have more structured data there. And data science can also be functional here, where you could just pull the data from one lake and do projection data or whatever your insights want to be or should look like there. Again, these are the components. One lake can be integrated to any cloud platform. It is not just for one. It can be Azure, Amazon, Google, anything, right? So I've made that very clear that it's not isolated to one platform here. It can be any cloud provider, or either it could be on-premise sources as well. Data can be pulled in and dumped into either on-prem or cloud. So core capabilities of Microsoft Fabric is obviously data ingestion through Data Factory, and that's for the traditional ETL pipelines. The ones that I want to highlight are these are the features that this is what you would use if you want, based on your use case. Every use case is different, so pick based on what you think is going to be very efficient here for your business. So for Data Factories, the point I wanted to make is you want to do any data ingestions, transformations with low code and end-to-end integration. That's where you use Data Factory. You don't have to build any code base there, and you also have an option to write more code if you would like to, but again, it's a choice, and based on your transformations and aggregations, you could add more layers to it, but this is the simplest form. You can just build a pipeline as quickly as 2 sprints and be in production. Lakehouse is used as a combination of data warehouse and data lake capabilities with SQL analytics endpoints there. So that's where you use Lakehouse versus One Lake. One Lake is a unified data lake for both structured and unstructured data. Think about One Lake as S3 in many cases. You could just dump your data there from One Lake. You could just service it to any layer, whereas specifically Lakehouse is used for data warehouse capabilities. Notebooks are just like Jupyter notebooks. You could just write any advanced analytics, have backend Spark jobs written in your notebooks. So people use notebooks when they want to use Spark, or you want to do parallel processing. That's where notebooks come into picture. And most of the developers like it because they can see the output as quickly as they just run a query there, right? So you do have that functionality. If you are a core developer and want to use or build things from scratch, you do have the notebooks there. Real-time Hub is where you provide end-to-end solutions for event-driven scenarios and streaming data. This is where we are going to go through a little bit more. This is for real-time data. We push the data and then it goes to Event House. From there, the data gets pulled in and you build, real-time dashboards there. Power BI, it's a standard BI service layer, you could build any kind of reporting and service it for you as an internal users for reporting purpose. So what are the components of real-time intelligence? I think, like I said, I'm trying to deep dive into the real-time streaming here. There are certain factors that you have to look into when you're trying to build real-time pipeline. I would say pipelines. There's nothing wrong in it. So the first is the event streams from where the data is received, and then it is going to land into event house. That's where all the data exists, and you can do KQL operations and whatnot in the event house. And from event house, you do real-time dashboards. As quickly as that event lands into the event house, the report can be built for the real-time dashboards, which is under 30 seconds reporting, or it can be milliseconds, but depends on your business needs. I don't want to vouch for anything here, but the more the real time, the bigger the cost you pay, because obviously you're streaming more and you're getting more events and you're processing more there. So that's where the cost factor comes into picture. And Reflex is for monitoring. We use it on top of the event house here to monitor, to see how many events have come, and is it a healthy pipeline, unhealthy pipeline, is something wrong. So you use that for Reflex. And real-time analytics plus data activator is used for the dashboarding purpose. So if you see further down to the, if I yes, yeah.
So if you go back one slide, right? I think a couple of things you mentioned. I think from a compute perspective, real time is heavier than standard load, right? Because it's always ready, right? Now, I think get the stream event house. I think the Reflex part of it, right? Like what is like you said, good or bad? Are we checking if the data essentially is Reflex very similar to Activator? Well, like how do I differentiate the Reflex versus Activator?
Yeah, that's correct. I think it's very in line with that. So basically, you're trying to check the health of the pipelines through Reflex.
So I'm watching so essentially, if I want to understand, the Reflex is checking if the data is coming in right or wrong, versus Activator is essentially triggering something. For example, I'm watching some kind of danger level or threshold level, right? So whenever threshold, Activator moves into action from that perspective, versus Reflex is saying that your essentially the health of the data ingestion or the processing is down or up.
You're absolutely right.
Okay.
Yeah, that's correct. That's correct. Activator is like a scheduler.
Essentially, Activator essentially watches the data, the content of the data, versus Reflex is watching the health of the ingestion, processing, and whatnot.
That's correct.
My fifth grade understanding, is that make sense?
You're right there.
All right, thank you.
Yeah. So moving to the linear architecture, once we have the data in the event house or in one lake, right? So the way that we process the data is into 3 layers. Once we have the data from the source systems, be it any source system here, we would directly have the raw data ingested into the bronze layer, as raw as it is, and then we process the data into more structured. So this bronze layer could be structured, or anything that can in its raw format is in the bronze layer. Once we move to the silver layer, we are more targeting it to making sure that we have right data types, creating a more structured stream here to make sure the data is in the right format. We don't have duplicates. We are eliminating the redundancies, and the formats is accurate. The formatting is accurate. So everything is is simplified in the silver layer. And once we get to the gold layer, we are doing more aggregations and trying to get to the being able to present to the business in a business ready format, where you would see, for example, in the silver layer, just in our example, we have data coming in from multiple systems, be in one telemetry raw JSON file, but you have different events coming in for different products, right? So Kahu, or be it FAI. So we can segment it into different layers in the silver layer and structure it to the business format. And then on top of it, you just do your aggregation based on the accounts or the devices, and then you can add more of the groups to make sure that data is in a more aggregated and viewable format, and you have one single table there to be presented for the visualization tool to be pulling the data from that table. So 3 simple layers: bronze, keep it raw; silver, structure it, clean up the data, structure it; and then presentable layer is gold layer. Are we good here? Any questions?
I do have a question. Sorry, I don't have a shortage of questions.
Yeah, sure.
So I think like here, like the data coming into bronze layer is processed by event stream, correct?
Yes, it's just a linear architecture with put together how we would, pull in the data from these sources.
Around the movement between bronze, silver, and gold. Are we like using it like some kind of like shortcuts, or is that also like some kind of RTI technology that moves the data between silver and gold?
No, you then, you just write case equals to be able to move the data from one layer to another layer. You don't need any technology there. Once it lands there, you are just writing your, cleaning up code. It can be just simple SQL code.
And if I'm not like, I'm going to make an assumption, but like I know we are starting to get materialized. We actually have materialized view on the regular Lakehouse warehouse. It's coming. It got just announced in FabCon, but KQL by definition has materialized views, meaning like with KQL is continuously materializing the views from silver and gold layer.
That's correct. Yes, KQL has that today. I think they're trying to. I guess I was not at FabCon, so you might have more insights into what they're opening up.
It is coming, right? I was trying to test it on our side. It's not out yet. They just announced that for lake houses and stuff like that, we're gonna get a materialized view, and I got too excited to start looking, reading, and only thing I can find for materialized views is around the RTI KQL side. And at the same time, I think just going a little bit side, I think there's a question from Ron in the chat, like data defect rules, like duplicates, nulls cleaned up and whatnot. Is that something we're cleaning up in Silver, or
Yes.
is that something that like the reflexes catch, or reflexes are more on the again the connection side?
No, so the data, whatever we are getting from the source is as long as we receive from the source. For example, if a batch, let's say a batch or a real-time streaming pipeline had some issue, and we have to go to the previous offset value to pull the data from the last offset, we just pull it and just load it. But at that time, it doesn't know if there are duplicates. We just keep it as it is. But when it comes to the silver layer, we clean up. We just make sure that there is cleaner data that passes through the. So that's where we call it silver layer, and more cleaner and more structured in the silver layer, whereas bronze layer you keep it as raw as it is.
Okay, I got two more questions. I think I can see from Ron's question, right? The data for KQL, is that in Delta Parquet format?
Correct. No, I mean, not in it can be in any format, Avro or Delta, depends. But based on however you want to store it. So it can be in Parquet format too.
But I think this is a clarification. Again, when we are using RTI, data lands not in a lakehouse, rather in a KQL database, correct?
Event house, yes.
So I haven't tested it. I'm guessing Event House also creates a semantic link and all that stuff that comes with like a lakehouse and whatnot. So we could shortcut the data back into a lakehouse if need be.
That's correct. Yeah, I have some slides here. I can. I think we are getting
ahead
here.
You just have to say that's a good question. This is coming.
Yeah, I guess I'm going to cover some of it in the next few slides here. So if
you can say, this was not prepped. Love the participation. Hopefully that answers your questions, Ron. Thrushna, take it away, sir.
Yeah, sure. If you see here the fabric, I put up some slides on the this test account that I have here. You see one fabric account, and then when you see here, you will see that inside that one cluster, you could go and spin up any service, right? And this all falls under the one big cluster that is being spun up. Anything can be spun up from there on. Once you have the warehouse set up, you will the cluster set up. You can spin up data pipelines. You can have Kafka topic streaming, Event Hub streaming, Azure one lake, anything can be set up from there on how your architecture should be based on your requirements. If your requirements say so that you just want to push the data to lake, you just push it to lake. You don't push it to event house, right? So depends on your requirements. So I have a small skimmed pipeline here where you would just build in a fabric monitoring. This is just drag and drop. I just wanted to show this because this is just drag and drop, and you can just in the end view these dashboards in like this, right? So once you have your source and the destination pulled in, you will just have the data in the KQL database, which is going to be Event House. And it's as simple as it is. You see all the data is being structured here. And you could write simple SQL queries. It's not complicated. I know when you say KQL, it sounds different. It just has some data types that you will have to be familiarized with. But it's as simple as just going and writing some select queries and then doing some where clauses to be able to just see the data. So I was just trying to, so whatever we had in the previous slide, the monitoring piece, we just trying to just run a query to see what all we have. Sorry, this is too, I didn't realize this was too tiny for anybody to view it. But
I think you can maybe go into the slideshow mode. That will make it bigger, I think. Presenter view, yeah. Maybe minimize that one. The other one is now bigger. Yeah.
Yeah, so if you see the, price, units, just some generic data here. All right. Okay, now I'm getting into the common use cases of KCQ. KSQL. So how are we using KSQL? It's, to be able to log and have telemetry events accessible as quickly as they have. And security threat detection is also covered. Again, these are not aspects that we implement. This is all implemented by Fabric team. It's done in the back end. It's just coming out of, just think about a black box being sitting on top of your organization and you're trying to pull things out. They do not share all those details on how they would, do those security implementation. But I'm just calling out because it's all, tightly coupled. There is nothing called data loss or data breaches happening with it. It's all secure. Data exploration, you could, like I've shown in my previous slide, you could just do a data exploration as you go, and you can start scheduling and using your real-time monitoring and alerting dashboards as you see the data come through into the event house. So what is KQL? KQL is nothing but a custom. I guess, like I said, we were running ahead. Just to explain what this is it's a simple custom query language, which is as simple as just writing. I don't want to compare it to SQL. Again, it's a wicked comparison, but you can like large amount of structured data and semi-structured and structured data and query the data very in a very simple format. The primary use is for the event house. Basically, we are using KQL in event house and Azure Data Explorer, and obviously log analytics and application insights. These are the primary uses of KQL within the Fabric, tech stack. This is where you use KQL, right? So key features is fast and scalability. Obviously, it handles large data sets effectively, and the querying process is not doesn't take long at all. It is used for analytics, and you can modify anything, and as you get the queries can be easily modified. SQL syntax is easy to learn. It's again not SQL. It is not the traditional SQL. Some syntaxes are definitely different. You have to just get yourself familiarized with it, and you have built-in functions for advanced filtering, aggregations, and visualizations within KQL. So like I mentioned, the major operations that we use in KQL operators are filtering, obviously, where you would in any SQL language you just use where clause. So here also we just use where clause. Aggregations are simple operators like counts, sums, averages, and whatnot. So you could expand more, but I just gave you some examples. Sorting and ordering is also order by, and top are the two functions that we use. And for join, it's simple as it is. There's no difference from the traditional SQL way. Here you just use join, union, inner joins, and whatnot here. And strings and timestamp operations are a little different. You just use contains for the strings and ago for the filter for the relative time. So when you are trying to use time operations, you just use a function called ago. So real-time dashboarding, like I said. So once you see the previous slide, I think 4 slides before you saw the data, right? Once the data is landed into the event house, you can quickly start pulling your visualizations. So you just write it and aggregate it, sort by this, and then you render a column chart with, so you could just quickly pull out your real-time dashboards. And within Fabric, I don't know if I had that slide. I can just go back, sorry. There is, oh no, I don't have it. But you would have actually a tab here from where you could just click on real-time dashboards, and it will directly, where do I see? Pin to a dashboard. Sorry, here you see here pin to a dashboard in the red right above my query next to copy query. If you do pin to a dashboard, that's what you will get. And you can also create your Power BI dashboards directly. You could just, for whatever query you wrote, you can just start creating your Power BI dashboards by just clicking on those buttons.
Is that dashboard like a standard Power BI dashboard, or is that
yes,
like a real-time? Is the real-time dashboard different than a Power BI dashboard?
So what happens with the pin dashboard is it just, whatever is the query output, it just spits and you just have to refresh. Create Power BI dashboard can also be that. Honestly, I did not write Power BI dashboards. I'm most invested into real-time dashboards because for, in many cases,
that's the thing. Like the real-time dashboard is not exactly the same thing as the Power BI dashboard, correct?
You could just pin it to see how you want to see it on a Power BI dashboard, right? So that's all. So it can be used. The data can be exported to a Power BI dashboard, but pin it. The real-time dashboards are a little different. They are more, like you said, Khalid, they're more real-time.
All right.
Going back. So obviously, what are we getting out of fully managed real-time analytics platform is we are making sure we ensure we have scalable infrastructure to handle data spikes. And we use linear architecture to have a more structured processing of data. At any given time, if we are having any failures, we still have the data in the raw format to be reprocessed. It passes through the, the bronze layer. And implementation is, we can have proactive monitoring and alerting systems in place for our, I guess that's all I had today, Khalid. I'm open for questions.
Sounds good. All right, let's see. I think we have first question. Why are the elasticity or scalable features managed? Is like given that Fabric has a tendency of bursting and smoothing and things like that, do we have some kind of elasticity feature for RTI? Is that something you're familiar with, Thrushna?
Yeah. So I think one feature that I think the elasticity comes into, I've seen a pitfall, honestly, with Fabric is that where, once you have a cluster and if you are, if you're spinning up a lot of resources on it, the thing would be you're falling short of resources, you have to scale up in terms of elasticity and the cost is going to go up tremendously, right? In that case is what we have seen is we just spin up another instance for that other project rather have everything serviced on one layer. So that's one of the flaws, honestly, that I've seen with having Fabric is you have to have a mindset of what you want to build, and being able to scale is something that you have to pre-configure, because if you don't and if you add more and more and more, the cluster might be overboarded and you have to go to a bigger one, and there is no scaling up and down and so easily with that because you have multiple services and there is a lot of dependencies. You definitely can't scale down, it's only scaling up. So we have to be careful there, especially cost, right, Khalid? So
Yeah.
that's
And I
that's
think
a big aspect.
the reason I understand, like think about, I think I wrote about it like a week or last week or something like that. Fabric's cost advantage is it's predictable, meaning what you sign up for is what you're gonna get billed for.
Exactly.
And all service is part of the same package. And like after April 30th, you're even gonna get Copilot standard built into every single SKU. But there's one more pro that they did, which is not like, but it's specific, right? So the workload isolation and auto scale is only going to be available at this point to Spark workloads. So this is one of the big announcements that came out in FabCon 2 weeks ago when I was in Vegas. That this is pretty good. I mean, I kind of didn't see this one coming, but Microsoft is going to allow us to have a separate workload dedicated to Spark, meaning so it will be kind of like Snowflake experience. You only pay for what you use.
Yeah.
But now the downside of doing this, like on the other side, is that one of the cool things in Fabric is it bursts, meaning that if you have a momentary high need of something, it can go from F2 to like F. I think it goes up to like 4 times its size and whatnot.
Yeah.
But it essentially pulls it from the future.
Correct.
That means if it spike last, if you run out of resource, it essentially shuts you down, right? So essentially the jobs will continue to fail. And at this point, we do not have an auto scale option. This was something we used to have in the Power BI Premium days that we could configure
Yes.
auto scales. Like if you are about to scale down, I am okay to pay for it, just go up to the next level. That part, I think we are missing right now. It's not something that we have in Fabric. I know they're working on auto scale up, not the pay as you go. I think we'll get that sometime later in the year, hopefully. That would be good. But other than that, that's a downside, meaning like we actually kind of have to watch the utilization matrix. For those of you not familiar with the Fabric capacity utility matrix, there's an app that you can install and whatnot to see what the utilization of your workload is. And then also recently, I think it's in public preview, that the capacity estimator or something like that. For that, I kind of find it's a good, kind of gives you an idea about what you're going to try to do, but in reality, it's specific to your data processing and whatnot. It's almost a trial and error to figure out what the right workload capacity size for you is. That has been my experience. Anything from your experience that you can share?
Yeah, I think you're on spot there. There are some of the challenges that you would see with Fabric 2. I've heard that there are more announcements on FabCon, which I've not been up to date with. But hopefully, if that scaling aspect comes into picture, it'll be more advantageous because, especially from the cost perspective, you will not burn off on resources, and nobody wants to get into that state, right? So
yeah, I mean, last thing we want to happen is your CEO opens the dashboard. It's like, you're out of capacity.
Yeah.
And I think especially on real time, that's even more a challenge is essentially if the capacity shuts down, what happens for the time that's shut down? How do you deal with the stream data that failed in the time process? I mean, but I think that's kind of the challenge. I think it's known, and hopefully they will solve it and whatnot. But what thing we should give credit to, I think some of the things Thrushna highlighted, all the security and all that stuff comes packaged out of the box, the SaaS nature of it, right? Would you say that like from a project perspective, the deployment time has gone down significantly, right? So like setting up the environment, getting it running and whatnot, how long it took before in the old days versus now, even just working from an Azure perspective or even like competing perspective, I think this SaaS nature, everything baked into one thing does that make a difference from our RTI in the old? I mean, RTI is still expensive, less expensive than before, but RTI, the moment anybody touches RTI, from all the analytics workload perspective, this is an expensive workload. But I think it probably has become more mainstream now with Fabric, given the SaaS nature of it. Is that a right assumption?
That's correct. So because obviously it's coming with advantages of making it easier to deploy with the SaaS platform. So that's one of the key benefits of having Fabric, right? And like the that you asked was it easier to have end-to-end workflows built with it? Yes, of course, it's much easier than having being working with multiple tech stacks and having eliminating that workloads across different streams has significantly gone down with Fabric for sure.
All right. All right. I think that's all the questions from my side. Any questions from the folks here? Thrushna, if people have questions, what's the best way to reach you?
Yes, you can reach me on my LinkedIn, or I can actually, you can reach out to Khalid. Khalid has my email. You could just send it out to me and I can answer any questions.
Yeah, let me kind of give me 1 second. Let me find Thrushna's LinkedIn profile. I'll put that in the chat. And then I'll also put up our Houston Fabric user group meetup, where you can find our next events. For the folks that are in Houston, we are going to go in person next month. We're excited to be part of the Global Fabric User Group Conference. So we are going to try to do a conference style for the first time on May 31st at the Microsoft Technology Center. We're going to have different folks coming in and speaking in person. And I'm trying to cause some trouble to get a hold of a few folks. So we can probably do a virtual one around the data agent. That's something I'm personally pretty curious about, which is very new and coming right now. So thank you everyone for joining. You guys can reach out to me on LinkedIn, whatnot. And then obviously the meetup link is the easiest way to follow all the events that's up and coming. And if you want to present on topic that's related to Fabric, Copilot, AI, data, Power BI, and whatnot, would love to see you present. And that's found the link this time. The link's in the chat. That's all from us. Thank you very much for joining.
Thank you, Khalid. Thanks, everyone.
Thank you.